So first of all, here is a small code that I have created. It's a very simple code which does matrix multiplication. So it's very, very simple. It takes two matrices, initializes them, does the multiplication, and based on the results, well, it generates the data. Now, what we want to do is, because we have two different files, we have a file for GPUs, we have another file for the host. We want to compile these files for debugging. So how to do that? First of all, we need to use the adequate compilers. So if we want to compile a code on the host side, we need the CC compiler. For the GPUs, we need NVCC. And as you can see, I'm using the -G flag, which is necessary for debugging. Now, I'm also going to add to link my application with the dmalloc library, which is part of the Allinea build. And this is necessary to enable memory debugging. This memory debugging will have a lot of things, will include a lot of things, such as detection of memory leaks, memory overflow, any kind of memory corruption. And the purpose of this library is to stop the execution of the debugger during a debugging session if a memory error happens. So it will force the code to crash. The purpose of this is to crash, even if the code would run successfully, is to crash your application. So if this happens when you're trying the debugger, keep in mind it's not a problem, it's not a bug. DDT is doing its job. It's just showing you where the problems happen in your code. So I'm just going to use this for this example. In the next webinar, we'll deep dive into memory debugging in more details. But for now, we'll just keep it to this. The other thing that is very important is to link your application with libcudat. So this is typically included in the CUDA path, lib64, libcudat. So this is necessary if you want to debug your code. Now, here I have specified a debug flag for my compilation, in which I will add a few additional things. So the O0, which is no optimization, and a -G for debugging. So these flags are not required, but they are very encouraged in order to have a clear picture on how your debugging session goes. So I'm going to compile my code, make debug = 1. So you can see here NVCC is doing its magic. I'm compiling the code on the C part, and I now have my wonderful binary nmod2.sh. Prior to this, I've forgotten to show you, but I have loaded my environment. So I've been using the CUDA Toolkit 7, the Cray environment, DD6.0, and the Cray PE accelerator NVIDIA 35. Okay. So now I have this. I want to start my job on the cluster. So again, this is what we have seen last time. All you need to do is take your job submission script. I'm going to remove this to make it clearer. So this is your usual submission. You don't change anything. What I'm going to do is, instead of running this command, so ap run with my executable 4000 and 4000, this is the size of the data, I'm going to add ddt --connect in front of this ap run command. And because I'm using a CUDA driver version 7, which doesn't match the NVCC compiler, I'm just going to add this environment variable at the beginning. Okay, this is something specific to the modules I have loaded. It's not necessary all the time, but in this particular case, I will need it. So with this script, basically, I'm ready to go. If I want to start, I just submit this script to the queue, and when the job starts, it will connect the debugging session to the graphical interface. So